Hello friends, I am Engineer Nasir. In this video we will study how to select the support for installation of HVAC ducting. For it we use two methods. Number 1, by using tables given in SMACNA according to the duct dimension. Number 2, by structural calculation using duct weight and duct dimensions. I will explain you both methods. If we are hanging our duct from the slab, then for upper attachment generally we use anchor. For hanger generally we use threaded rod or metal strips. And for the lower attachment we use steel angle or channel. Now I will explain you how to select the diameter of hanger or anchor and how to select the angle or channel for the duct support. First we will study how to use SMACNA tables to select the duct support. We use this table from SMACNA to select the hanger rod diameter or strap size for a duct support. The first column of this table is showing the maximum half of duct perimeter, and the next columns are showing the rod diameter or strap size with respect to the spacing between two supports. What is duct perimeter? It is the sum of all four sides of a duct cross section. You can see in this picture it is the width of the duct and it is height. Then the perimeter will be equal to 2 times width plus height. Then P by 2 value will be duct width plus duct height. If you are using spacing 3 meter between two duct support, then you have to select the rod diameter from this column. If you are using spacing between two support 2.4 meter, then you need to select the rod diameter from this column. If you are using the spacing between two duct support 1.5 meter, then you can select the rod diameter from this column. And if you are using 1.2 meter spacing, then you need to select the rod diameter from this column or strap size from here. We can select the rod diameter or strap size for a duct support in other way also. For it, first you should know the spacing between two duct support. Then calculate the weight of a duct of the same length. Suppose we have spacing between two duct support 2.4 meter. Then we will calculate the weight of a duct of 2.4 meter. Let us assume the weight of a duct of length 2.4 meter is 400 kg. As you know, for a duct support we have two hangers, so we will divide it by 2. So for one hanger we will have the weight 200 kg. Then from here we will select the rod diameter for 200 kg. You can see up to 122 kg you can use 6.4 millimeter rod, and up to 308 kg you can use 9.5 millimeter rod. So we will select the rod diameter 9.5. Similarly, if you need to use the strap, so for 200 kg we will select this weight 318. So you can use a strap of size 25.4 millimeter with a thickness 1.61 millimeter. We use this table to select the angle or channel size for the duct support. The first column we select the angle or channel length for the duct support. Then in between this portion we have to select the weight of the duct. Then from here you can select the required channel or angle size. Suppose we have a duct with a width of 800 millimeter. Then for support we always keep 50 millimeter right or 50 left. So then we need a angle with a length of 900 millimeter. Then we will select the 900 millimeter from here. We can find here. Then we will select this row. Then in this row we will find the weight. Suppose we have this duct weight 400 kilograms, so we will search 400 kilogram, 281, this is less than 400, then 417. Now we will select this 417 column. So for this duct support we have selected the angle of size 51 by 3.8 millimeter. To select the hanger for round duct we use this table. For a round duct up to diameter 250 millimeter with a spacing of 12 feet or 3.7 meter, we can use a rod of 6.4 millimeter or a strap of 25.4 millimeter with a thickness 0.85 millimeter. Similarly, for a round duct of diameter up to 460, we can use the same diameter of rod and same strap. For round duct up to 610 millimeter diameter, also we can use the same rod and strap 25.4 millimeter with a thickness of 0.85 millimeter. For a round duct up to 900 millimeter, we can use a single rod of 9.5 millimeter diameter or a strap of 25.4 millimeter with a thickness of 1 millimeter. Then for a round duct having diameter greater than 900 millimeter and up to 2130 millimeter, we need to use two rods having diameter 9.5 millimeter. You can see in this picture, this is round duct support with single rod and this is round duct support with two rods. Now we will study how to select the duct support by structural calculations. First we will select the angle or channel size for duct support. For it we will make calculation for deflection, bending stress and for shear stress. We will do a sample calculation for selection of steel angle for the duct support. Let us assume we have a straight duct having dimension 700 by 400 and the sheet used for the fabrication of duct is 22 gauge and the distance between two support is 3 meter. First we will calculate the duct weight that will be supported by a single support. For it we will take the duct length equal to the distance between two support, which in our sample calculation is 3 meter. Then we will calculate two types of duct weight. Number 1 total duct weight, which we show here by P, and number 2 weight of duct bottom and duct top, which we are showing here by P1. As we are using sheet 22 gauge and for 22 gauge weight is 6.86 kg per meter square. Then we will calculate the area of the duct for 3 meter length, which is 6.6 meter square. Then we multiply it by 6.86. Then the total duct weight is equal to 45.28 kg. Similarly, the weight for the duct bottom and top is 28.81 kg. To calculate the deflection, we use this formula. And for this formula, we need the duct weight that we already calculated. A, we are using 50 mm clearance between the hanger rod and the duct on the support. If both side clearance is 50 mm and duct width 700, then the length of the angle that we are using for support will be 800 millimeter. So L will be 800 millimeter. And the modulus of elasticity for the steel is 200 GPa. Moment of inertia we will select from the steel properties table of the angle. We use this table to select the angle properties. First we will check for angle size 40 by 40 by 3 millimeter to check if this angle is safe to work for our duct support. From this column we will select the cross sectional area, which is in centimeter square, and from here we will select the moment of inertia, and this column is for section modulus. So for the angle size 40 by 40 by 3 millimeter, cross sectional area is 2.336 centimeter square and moment of inertia in centimeter is 3.53 and section modulus is 1.21 cubic centimeter. Weight and angle properties we fill in this table. For duct weight we consider 25% safety factor. Then the duct total weight will become 555.246 Newton and the weight of bottom and top of the duct will be 353.28 Newton. A 50 millimeter section modulus we have converted to millimeter cubic 12100, and moment of inertia will become in millimeter 35300. The value of modulus of elasticity in Newton per millimeter square will be 200,000, and the cross sectional area for the angle in millimeter will be 233.6 millimeter square. When we apply this value in this formula, we got the value of deflection equal to 0.8958 millimeter. To calculate the maximum allowable deflection, we use this formula, length divided by 360. Then by this formula, we got maximum allowable value for the deflection is 2.22 millimeter, and our calculated value is 0.89, which is less than allowable value. Or you can use the maximum allowable deflection limit from SMACNA. As per SMACNA, maximum deflection we can have up to 9.5 millimeter. The formula given in SMACNA is little bit complicated, so to make it more simple and more safe, we consider it point load at center. Then when we apply these values in this formula, the deflection in this angle is, due to this duct weight, 0.83 millimeter, and the allowable maximum deflection for this angle length is 2.22 millimeter. So as per deflection, this angle is safe to use for this duct support. Now we'll do calculation for shear stress and bending stress using point load method. Then maximum allowable duct weight for this angle is 2462 as per shear stress, and as per bending stress, maximum allowable duct weight is 63.7 kg. Both these ducts are more than our duct weight. So as per shear stress and bending stress value also, this angle is safe for this duct support. To select support for different size of angle, we make an Excel table. You can see for duct size 700 by 400, 22 gauge. Total weight for one support 45.28 kg. When we use 40 by 40 by 3 millimeter angle, deflection in the angle is 1.00 millimeter and allowable 2.22, and as per bending stress, allowable duct weight is 63 and our duct weight is 45. As per shear, allowable duct weight is too much, 2462. So this angle is safe for this duct weight support. But if we want to use the same angle for another duct size 1000 by 500 and gauge 20, total duct weight for one support 76.65 kg. Then the deflection in this angle became 4.44, which is greater than allowable deflection 3.05. And as per bending stress, maximum allowable duct weight is 46 kg and our duct is 76. So this angle is not safe for this duct support. Then we need to select another size of angle. When we select 50 by 50 by 4 millimeter angle, then the deflection value in this angle is 1.72 and allowable 3. And also as per bending stress, maximum allowable duct weight is 95, our weight is 76, so this angle is safe for this duct support. Again, if we need to use the same angle for another bigger size 1300 by 700 gauge 18, then the deflection value became higher than allowable, and as per bending stress, allowable duct weight is less than duct weight, so this angle is not safe for this duct. Then we will go for next size of angle 75 by 75 by 5 millimeter, and for this angle deflection also is less than allowable angle, and as per bending stress, maximum allowable duct weight is higher than the duct weight, so this angle is suitable for to use for this duct support. Selection of anchors. For selecting anchor for duct support, we use its specification sheet. You can see in this sheet, the first column is showing the anchor size, and from here we can select the maximum recommended shear load in kilonewton, and it is maximum recommended tensile load in kilonewton. For hanging rod, we will consider the maximum recommended shear load value. For duct support, normally we use minimum 10 millimeter rod size, and for it we will select the 10 millimeter anchor. For 10 millimeter anchor, for hollow concrete slab we have the maximum recommended shear load value 3.6 kilonewton, and for non-crack concrete slab maximum recommended shear value is 4.93. If you need to convert it in kilogram, then you can multiply it by divide by 9.81 and multiply by 1000. Then you will get the maximum recommended load for 10 millimeter anchor equal to 502.548 kilogram. Selection of threaded rods. To select the hanger or threaded rod for duct support, you can use this table from ASME B31.1. In this table, the first column is for rod nominal diameter, and if you want to select the corresponding weight in kilogram, then you can select from the last column. For a threaded rod diameter 3 by 8 millimeter inch or 9.4 millimeter, the corresponding maximum load value is 276 kilogram, and for a rod of diameter half inch or 12.5 millimeter, the maximum recommended load is 512 kilogram. So from the first column you can select the rod diameter, and from the last column you can select the corresponding maximum load in kilogram.